Thank you for watching Knowledge Academy. So in this topic, we're going to be talking about triple integral. So I have two things to discuss here. The first one is use triple integral to calculate the volume of solids. Number two is use triple integral to calculate mass and discuss other application of triple integral. When I say discuss, we're going to be talking about a little bit because mass is the easy one, the later one are difficult. We're going to just touch those topic a little bit. Okay. So let's jumping and starting triple integral. We learn about use of volume, so we're going to say the unit of a volume in a rectangular coordinate. We can write like this. So I have a cube, right? And this cube is basically giving in three coordinate. This one is z, this one is y, this one is x. And if I want to write this volume, I'm going to take this guy, which is delta y, this guy is delta x, and this entity is delta c. So I'm going to write here delta x, delta y, delta z. Right? If I have a three-dimensional object, let's suppose like this, and it should be same way I'm going to be drawing. Like this shape. And if I'm asking you calculate the volume of this shape, what you're going to do is you're just going to go into the center of this, wherever you're going to go to here, wherever, and just taking a little cube, right? And then again call it delta y, so delta x, delta y, and delta z. Okay, you can call this way, or the best way we can call in differential form, we call them dx, this dy, dx, dz. Okay, and then x, the y limit is going to go from y equals to 0 and y equals to I don't know, because this the equation of this side is my limit. Same thing I'm going to say is x equals to 0 and x on this face, this front face, x I don't know, but x is the equation of this face. Same thing on this point, z equals to 0, and then when you go up in this surface, z I don't know, because I don't know the equation. If I want to write this one in the form of triple integral, I'm going to be writing the volume of domain D. Here the D is this solid, right? That's my domain for this D equals to. I'm going to be now I'm going to be using triple integral as a finder of this volume. So I'm going to write in this little thing, I'm going to call it D V, which is basically this guy. Right? This is also can write delta V. So I'm going to say dV. So I'm going to writing here dV, and here I'm going to be writing domain. This one is dV. It could be dz dy dx, dz dy dx, or dx dy dz. It means I can, if I'm doing this, I can make a dx and dy area. So dx and dy is basically like this, like the bottom of this, this patch, the bottom of this patch, like this guy. And then I'm going to make the dz, and I grow up to find the dz. Same thing here, I have a dz and dy. So really I have the area of back side of the cube, which is this back side of the cube. And then I can grow this way to finding my dz, dx. Okay. You can write any other way. You can also write this one as dx dz dy dx dy dz. Right. I'm gonna call R. You decide whatever work best for you. But technically all three should give us the same answer if we solve a triple integral. The order of dz, dx, dy based on my needs and how complicated is my integral, right? So I can also write, and then when I write this one, I'm going to be writing, like for example, I'm going to be writing just one, says volume equal to 1, 2, 3, then dz dy dx. So if I say dz, I'm going to be substituting the value of this z. So z equals to 0, z1. I'm going to call z1 to z2. These are the two units. Okay, the best way you can say, not always 0, z1, z2. When I say solving dy, I'm going to be solving dy. So I'm going to say y1, y2. We're solving dx. I'm going to be saying x1 to x2, just like we did double integral. Let's take a look examples. But before the examples, we can write the theorem. Okay, theorem is pretty much same way. You can write triple integral like this. I have a function x, y, z. The volume is given dv. Here is I have a domain. I can call q is my domain. And here I can write limit delta approaching to 0. Right? And inside the summation, I'm going to write in I equals to 1 and 2 approaching to n. N is my number of distribution or discretization of volume. And this is my delta vi. When you expand this one, you're gonna go back to pretty much this integral. That's what we wrote here. Okay. Now take a look on this example. Let's take a look another problem. Find the volume between the xy plane and z. 6 minus 3x minus 2y above the unit square. R, and the unit square is given R. That is my pretty much like a region. We used to talk about region in 2D. Region still is going to stay there because region is the one who's the foundation of volume or base of the volume. And the region is given from x starting from 0 and going up to 1. Y starting from 0 and go up to 1. Okay. So really, if you think about it, how we're going to take a drawing of this image of this scenario, that's going to really help us. So really what we have here, we have a 3D scenario. And I have a plane given in this problem, probably, and I have a plane is given for this problem like this. This plane equation is giving this. Z equals to 6 minus 3x minus 2y. When you drop down this plane, right, drop down from this plane like here, here, and here, this guy is my R, this R. This plane is starting from 0, here x equals to 0, here y equals to 0, and it goes up to 1, y x-axis. Same thing in y, it goes up to here. It goes up to 1, x equals to 1, y equals to 1. This is my y-axis, and that is my z-axis. Okay. In order to solve these kind of problem, I told you when you're writing, whatever operator you're writing, you should be writing accordingly. So if we used to do this problem in double integral, right? In double integral, we used to write this, and then writing the function c, then d, y, dx. So you can write in double integral 0 to 1, 0 to 1, and then 6 minus 3x minus 2y dy and dx. Okay, this is if we used to write in double integral. Now I want to do triple integral. So I'm going to be writing 1, 2, 3. And then I'm going to start this thing from the top. So it's going to be look like R. Right? And that is my x-axis. Maybe this is my y-axis. And what I'm going to make same thing. I'm going to make the line like this when I solving the dy. And dx when I solving the dy, it's going to be line like this. So these are the two limits: 0, 1, 0, 1. So what I'm going to write here, I'm going to be writing like this: d, and then I'm going to be making a line from this way. So maybe I can see this. I can rotate this one for d. See, and I'm going to making a line. It's going to be look like this. And my line is going to be passing like this. So this is my z-axis. This is my maybe x-axis. I don't care about which axis that. At this 2 point, I'm going to be cutting. So it's going to be 0, and then the equation of this plane is 6 minus 3x minus 2y. Just given. So I'm going to be writing like this. dz dy dx. And I'm going to substitute the values of these limits. Is going to be 0, y equals to 0, x equals to 0. Because all is starting from the bottom, doesn't matter if I go here, here, or here. The upper limit of this z equals to this plane, since it's cutting over here, this is z value. So I'm going to substitute here, z equals to 6 minus 3x minus 2y. Here I'm going to substitute in y equals to 1 and x equals to 1. Okay. Moving forward, I'm gonna be writing this again and again. It's gonna be too much writing. I'm gonna be just writing like this: 0, 6 minus 3y, 3x minus 2y, then 1, 1, 0, 0, and then writing my differential element order. This order is still very important. If you switch back and forth, you have to change the limits accordingly. Yeah. Let's solve this one. When we solve this one, the first integral, I'm going to be solving this. It's going to be look like 0 to 1, 0 to 1, and then first integral is just a z. Z limits are 6 minus 3x minus 2y, and then 0, then dy dx. Okay, I'm going to substitute the limit. Is going to be 6 minus 3x minus 2y minus 0. Okay, and dy dx. Now I'm going to be taking the integral with respect to y. So it's going to be 0 to 1, and it's going to be 6y minus 3xy minus 2 over 2 y squared, and then 0, and then dx. And the limit is 1 to 0. I'm going to substitute the limit just for simplicity. I can just say 2 over 2 is 1, so I'm going to just remove this. Let's substitute the limit here. It's going to be 6 minus 3x, 6 minus 3x minus 1. So 6 minus 3x minus 1. If I substitute the limit minus 0, I can simplify this one. It's going to be 6 minus 1 is going to be 5. So 5 minus 3x and then dx. So I'm going to write here 5 minus 3x dx. Yep. Let's do the last integral, the third integral, so we can get the answer. It's going to be 5x minus 3 divided by 2x, and the limit is 1, 0. Let's substitute the limit. 5, 1 minus 3 by 2, 1 minus 0. It's going to be 5 minus 3 by 2. If I solve this, 2, 10 minus 3. So 7 over 2 is my answer. Okay. Let's take a look at another problem. Let's look into this another example. Find the volume of a prism in the first octant bounded by the plane, and the planes are giving z equals to 4 and y equals to something. So planes are z equals to 4 and y equals to 6 minus 3x. I'm going to draw the diagram for this. Okay. So find the volume of the prism in the first octant. Remember I told you there's a quadrant and octant, right? First quadrant means 2D, octant means 3D. So if I say quadrant is going to be drawn like this. This is first, second, third, fourth. But if I want to do the 3D, I can make it 3D. So this is the block. You're going to make the box here. This is the first octant. Next one is the second one, the third one, then fourth one. The back one is fifth, sixth, seventh, eighth. So really you can go on the back too and make this one. Then you're gonna make over here one, then you're gonna make one over here one, and then you can make two on the bottom and then two on the back of those two bottoms. So what I'm gonna do, I'm gonna draw the diagram. Since I'm only talking about the first octant, so I'm going to be focused on the first octant, this one. So I'm going to be saying this is my y, this is my x, this is my z. And I have two limitation given, z here and then by this. So z I'm going to be going up to z equals to somewhere here, z equals to 4. And there is a plane, this plane is giving in the front. So my prism is going to be look like pretty much this. This front face, the front face, the face we have it towards us, which is basically the pink color face. You know, this pink color boundary is toward us. The equation of this given is y equals to 6 minus 3x. The top plane we already talked about, top equals to z equals to 4. Okay, the back side is a xz plane, xy plane, and then the yz plane, and then the xz plane, the two sides. Okay. If you want to solve this one, I'm going to see from the top. If I see from the top, it's going to be look like a rectangle. And if I see from the top, it's going to be look like rectangle, something look like this. And what I'm going to do, I'm going to make the line. This line is cutting here, cutting here. Okay. This is my y plane, this is my x plane. This is my y plane, this is my x plane. So I'm seeing from the top. And this line, I'm going to draw, this line is going to be like this line. So not here, but I'm going to be drawing maybe here. Yeah, this line is here. This is very important. We should be making these diagrams to making those lines to cut. In order to do this, definitely on the bottom of this plane, z equals to what? 0. On the top of the plane, z equals to 4. So I'm going to choose bottom because bottom is my r. And z equals to 0. When I substitute z equals to 0 on the bottom, I'm going to finding the value of y. And here I'm going to say that 0 equals to 3 minus, right? At this point, I'm going to maybe say 0 equals to here, y equals to 6 minus 3x. So if I substitute y equals to 0, right? If I go all the way down here, this point, I'm going to substitute the y equals to 0 when I'm solving the x. So I'm going to say y equals to 0, 6 minus 3x, and x equals to 6 divided by 3, 2. So I got my two values of x equals to 2 and x equals to 0. So I'm going to be writing my volume. expression, which is v equals to 1, 2, 3. Then I have a dz dy dx. Z value is giving already 0 to 4, which is not an issue. Y value is giving from 0 to this expression 6 minus 3x. And if I substitute the value of y equals to 0, I got this value x equals to 2. So I'm going to substitute 2 here and x starting from 0, 2. Okay, now it's fairly simple to solve it. Just to re-emphasize, you must be making these diagrams and making these lines called vertical test, okay, to cut off these planes to finding those intersection points. Otherwise, you're more likely making some mistakes. So I'm going to be doing this 0 to 2, then 0 to 6 minus 3x, and then substitute the value for, take the integral for this one. So it's going to be z dy dx, and then limits are 4 and 0. If I substitute the limit into this, it's going to be 0 to 2, 6 minus 3x, then 4 dy dx. And if I substitute taking the second integral from this, it's going to be look like this. So 4 times, I'm going to write 4 times this. So 24 is going to be 4 times this, like this. So I'm going to be just simplified this a little bit. 4 times is 24, minus 4 times 3 is 12. So 24 minus 12x. Okay. I'll be writing here 24 minus 12x dx. I'm going to take the last integral. Just take the integral now. It's going to be 24 x minus 12 divided by 2x 2. Substitute the value 48 minus 6 times 4 and minus 0 is going to be 48 minus 24 minus 0. Solve it, it's going to be 24. Okay. Let's do another problem. I'm going to call another words here just so you know we can keep it as a reference. Evaluate the integral, or we can call it triple iterative integral. Remember the topic when you start, we use the word iterative integral. Iterative integral means really we take the iterations, small dx, dy, dz. So triple iterative integral. An integral is given to us is this. Here we don't have any diagrams given. We don't have any wordings are given because we already have the integral is given. So if you recall, I told you that integral, double integral, or triple integral, there's a three-way question can come. The first question is simply giving the integral just like right now. You don't have to do anything, no diagram needed. You just solve it. That's about it. The second one, some wordings are given, and then based on this wording, you have to make a diagram and writing the integral expression. Expression is not given. In some problems, some wording is given and some diagram is given, but the expression is not given. Based on the wording is given, which is explanation of the domain, from where to where the x is going, you have to create your own, expression. The last one is going to be only a diagram, a detailed diagram given to you or graph is given to you. We have to create our own integral based on the given information. Okay, so this is the easiest one or most less hassle. You don't have to make any diagram and make some judgments. So I'm going to be writing this one. So I'm going to be solving this part for dz. So it's going to be 2, 0 to x, and it's going to be exponential ex, then yz plus 2 divided by 2 z square. So I'm going to be just erasing them. Or 2 divided by is 1. Yeah. And the limit is x plus y 0. Then dy dx. Let's substitute the limit. Ex. Then when you substitute the x plus y, I'm going to simplify this x plus y squared is z. And you simplify it is going to look like this. Plus 2x to y squared. Then dy dx. I'm going to take the integral for this part now. And it's going to be 3x y squared over 2 plus 2 over 2, so 2 over 3 y cube dx, and the limit is x and 0. Now I'm going to be simplified a little bit more before I do the third integral. So it's going to be 0 to 2 and 19 over 6 x cubed ex dx. I'm going to take the integral for this one. There's going to be 3 okay. If I put in your calculator for this exponentially squared, right, to give you some value, you're going to take and divide by 3 plus 1 times 19. So answer would be 65.797. And that is my answer. I wouldn't say is volume because I don't know if it's a volume or something else. It's not given in the problem. Okay. We're going to do more problems, and then we have another topic. We're going to talk about that the mass determination through an integral where the density function is given. So we're going to talk about how we calculate mass by using triple integral of an object. Evaluate a triple integral given in this function, and the triple integral is given something like this. Go d z. Sometime when we set up our own integral, we have an opportunity, we can switch back and forth these operator. But if it is given in the question, just like now, we should not be changing anything because this is what the given condition, and we have to solve what is given. In this problem, I'm going to be start from doing from the center, so I'm going to be starting from here. It's going to be 0 to 3, 0 to 2 outside, and then inside of the parentheses is going to be x squared divided by 2 plus xy plus xc. We're going to do the second portion of this, applying the limit for 1 to 0. And it's going to be 1 is going to be half, and apply the 1 plus y plus z. We notice one more thing. You notice that in this function, it's fairly simple function, but as soon as we use the dx, right? We use the dx, you can see the dx actually including in all the terms. And that's a great example to know that when we have an opportunity to select dx, dz, dy, if we select something differently, let's suppose if I have an opportunity to select by myself, maybe I can see dz, dx, dy, and that the order is going to be changing. How complex the function is going to be getting more and more complicated or getting more and more simpler based on the order of these differential operators or integral operators, right? So I'm going to be just continuing with this one. The second part of this one, I'm going to be taking the integral directly. So it's going to be half z plus yz plus z squared divided by 2 dy. Limit is 2 and 0. Okay, let's substitute the limit. We're going to substitute the limit, going to be 0 and 3 is left over outside. Inside is going to be 2 over is going to be 1 and 2 c, so it's going to be 1 plus 2y plus 2. 4 divided by 2 is going to be 2 dy. I'm going to take the last one and apply. When I apply 0, everything becomes 0, so I'm not going to write it here. So I'm going to apply the last one. It's going to be 3y plus is going to be y squared 0 and 3. Let's substitute the limit. 3 plus 3 squared minus 0. It's going to be 9 plus 9 minus 0. Answer is 18. Let's take a look another problem. Iterative integral. In this integral is given like this: 0, 0, 0. Those are our lower limit, and the upper limits are 2, 1, and 2. The function is given x, y, z cube, dx, dy, dz. Okay, start this one. I'm going to be solving the first one. So writing the 2 like this. So it's going to be x squared yz cube divided by 2. Limit is 2 and this limit is not mega correction. This limit should be -1. Okay, then dy dz. Let's substitute the limit before we move forward. It's going to be 4 4 over y z cube divided by 2. Okay, and then dy is going to be -1 too. So I'm going to be substituting here, then minus y z cube divided by 2, and then dy dz. When I take this one, I'm going to be take minus, and this should be 1 plus. So it's going to be 3 y z cube divided by 2 dy dz. I'm going to take the second integral, right? Maybe I can just go up. And here is going to be 0 to 2. And if I take the integral, is going to be with respect to y, is going to be 3 over 4 y squared z cube. And the limit is 1 to 0, and then d z is outside left. Let's apply the limit before we do anything. When we apply the limit, is going to be 3, since y is 1 and is 0. So the first term is going to be 3 over 4 z cube minus 0. We don't want to be writing this one, so I'm going to just erase this and write it directly d z. It's a fairly simple integral now. I'm going to take the integral directly. 3 over 4 dot 1 over 4 z to the power 4 1 0 is going to be 3 over 16 z 4 minus. I'm going to just apply this directly here, and it's going to be just 1 and minus 0. And if I apply, it's going to be, I think I messed up somewhere 2 2. Yeah, it's going to be hold on. This should be, yeah, that should be 2. 2 to 0, so I'm going to apply here. 2 to the power 4 minus 0. And this one is 16 So we'll be cancelling out. So my answer is 3. Okay. Let's take some other kind of problem. In those problems, we just have to be setting up the integral, but does not need to be solving. Setting up a triple integral okay, do not solve. So number 1 is given something look like this. The solid in the first octet. We have to read these wording and then setting up the integral. Bounded by the coordinate planes. Coordinate plane means xy plane or yz plane and xz plane. And the plane z equals to 7 minus x minus 2y. You maybe pause this video and try your own. How are you going to do it? In this problem, we have a solid in the first octet. First octet, I already told you, octet is nothing but it's just like a quadrant in 3D, bounded by the coordinate planes. Coordinate planes are giving something like this, and there is a the plane. The plane is given. So maybe I have something look like this, and then the plane is given to look like this. Right? Nothing is being need to be drawn here. Really, that's the trick here. We have to just do it without doing anything, just setting up the plane, the integral. Okay. 1, 2, 3. The function is given. Only the limits I have to be used to book my the end point of this solid, right? I'm going to use the limit to book my end point of the solid. So I'm going to say dz dy dx. Since this is a dz plane, right? This is a dz plane, so I'm going to be using this as a benchmark. So I'm going to be applying this limit look like this. Go here, 0 and z. And here z equals to 7 minus x minus 2y. When I go to y, I apply z equals to 0. So I'm going to say z equals to 7 minus x minus 2y. So you think about it. If you have any shape look like this, right? And when you try to setting up the y one, you are at the bottom. Right? You come down. Remember I told you the line rule. I'm going to make a line. This line is cutting the plane here. When this plane is z equals to 0, at this cutting, this z value is this value. So I'm going to take this value of z and then says z equals to 0, 7 minus x minus 2y, and then grab the value of y from here. It should be the function of x. So I need the value of y, which should be the function of x. So I'm going to take this guy on the other side. So 2y equals to 7 minus x, and y equals to 7 minus x over 2. I'm going to take this as my upper limit of y. And I'm going to write here 7 minus x divided by 2. Then I'm going to go back again and then substitute this value of y equals to 0 when I find this point. At this point, y equals to 0, z equals to 0. X, I don't know. So what I'm going to do, I'm going to take the equation like this equation. For that equation, the first equation, I'm going to say 0, 7 minus x minus 2, 0. Zn, these both z and y is 0. And I'm going to find the value of x equals to 7 minus 2, which is equals to, 7 minus 0. So it's going to be x equals to 7. That is my x limit. So x is also going from 0 to 7. Okay. Let me just do another problem in the same slide. And I'm going to pass in some words. Based on this given condition, we have to set up the integral. The solid bounded by z equals to 9 minus x squared, z equals to 0, y equals to 0, and y equals to 2x. Z equals to 0, y equals to 0, and y equals to 2x. Okay. Here I'm going to be making three integral. Dz, then dy, then dx. I don't know who is who and how I'm going to be solving this, but carefully take a look. Let's pause this video maybe. You need to try your own. Here is pretty simple. I have this is z given, so I'm going to say 0, z equals to 9 minus x squared. The second part, when I say 0 equals to, so z equals to 9 minus x squared, I need to find the value of y, by the way. I'm going to substitute the value equals to 0 for z, 9 minus x squared. Here I'm going to be saying x equals to x squared equals to 9 and x equals to plus minus 3. So x equals to 3 only, okay? Because I don't use negative value for the volume. Now what I'm going to be doing, I'm going to leave this thing, but on the y, I have both conditions are given. One is here, one is here. So I simply write in y equals to 0 and y equals to 2x. The third part, x is not given, right? So I'm going to starting x with 0 to 3. Pretty much. Let's looking at another problem. Now in this problem, we need to find okay. In this problem, where the shape is given look like this something. this kind of shape, and then this shape is going up like this. So it's this shape up here this way. And then we're going to be just drawing a elliptical shape which is going on the top. It's kind of a solid face. Equations are given. So the back side of this is this side. You know, the back side of this is this side, and it's kind of a like if you see from the side view, it's going to be look like this, right? And this face like this round face is the face we are given here. So in this problem, this guy is going to 2 here, same thing, 1 minus 2 here. Here is going all the way down up to 4, so 3, 2, 1. And in the height is going up to this value is up to here is about, I think it's 5 something, a little bit over 5. 3 equations are given. The equation of this face is given x equals to 4 minus y squared. The equation of this plane, the top plane is given y is equals to 4. And the side is given like bottom part of this bottom plane, this one. You know, I'm going to say is yeah, the bottom of this face. Maybe I can say I should draw here. Take a bottom face is equal to z equals to 0 because z is going to be 0 on the ground on the floor. Okay, we need to set up something and solve it. In this problem, nothing is given. We have to draw everything by ourselves. The integral is not given, just a diagram is given. So how we need to solve it? We need to just write integral and starting from there. I'm going to go dz, dx, dy. In dz, I'm going from here, right, to all the way down up to x, right? No, this is not x. So my z value starting from 0 and go all the way down up x. So I'm going to write in here 0, right, to x. Y value is given here. So what I'm going to be doing in y value going this way is my y. So this way is my y. So it's going to go from 0 to 4 minus y squared. It's going to be y squared. 4 minus y squared is given also. And for my y value, or y operator, is going to be go from minus 2 to 2. If you can see here, 2 to minus 2. Okay, that's pretty much what we got. And then let's start solving this one. If I solve the inside one, is going to be z, right? Just going to be z, then x, then 0. I'm going to apply this limit directly, so it's going to be just x. I'm going to solve this guy. It's going to be x squared divided by 2. It's going to be half x squared, and then 4 minus x y squared, sorry, y squared, and then 0, then dy. I'm going to substitute the limit here, so let's do it here. I'm going to take this half out, and then 4 minus y squared. I'm going to apply the limit. Minus 0 is going to be everything becomes 0. Okay, and then dy. Let's open this identity. If you remember, I'm going to be writing this 4 minus y squared. I can write this one 2 squared minus 2 squared. Oh, sorry, y squared. So it's going to be a squared minus b squared identity, which is a plus. It's going to be square. Should be square here. So you can write a plus b square root right here. Is going to be a minus b squared. So square root is going to equal to a squared minus 2ab plus b squared. So I'm going to be using this to solve this expression. To open it up, by the way. So I'm going to be writing half integral 0 to 2. Okay. And it's going to be 0 okay, so 4 times 4 16 minus 2 times 4 8 y square plus y to the power 4. Okay, and then dy. I'm going to be taking the integral, put the rest of the stuff inside. So 16 y minus 8 over 3 y cubed and plus 1 over 5 y cubed 5 to the power 5, and then the limits are 2 to 0. Okay, let's substitute the limit directly. So it's going to be 2 16 16 times 2 minus 8 over 3 dot 2 to the power 8 to the power 3. Then minus everything becomes 0. 16 times 2 is 32, and then to the 4 8 8 times 8 is 64 divided by 3, and plus this is 2 to the power maybe 22 divided by 2. Okay, we can just solve this one, and it's going to be, maybe I can just make it this guy. 32 divided by 2 will be 16. So I'm going to take 3, and 32 times 3 96 minus 64 plus 48. So let's do it. 96 minus 64 plus 48 divided by 3. So I'm going to say it's 80 divided by 3. This one may be 40. Okay, let's raise this thing. Okay, maybe we just leave it here. We don't want points. Okay, now I'm about to start a short discussion about mass and volume, and maybe we can take a look in a small problem. Let's review a quick topic called density. Right? We learn in physics, we learn in chemistry, density is equals to mass or volume. Sometimes we call density equals to this, and mass is m, volume is v. If I need the mass, I can also do this times v and get the mass. Okay. Our goal in this topic to connect in our calculus discussion is, if I'm going to call this mass, I'm going to call if density is given, we can multiply density by volume to determine mass. Okay. In calculus, we call this density is called a density function. All right. So what are you going to do? Density function, it means in triple calculus, we can write this. We can write this whole function such as, right, we have given 1, I need the mass, right, this is the mass I need, so I'm going to be writing mass, and I'm going to be writing 1, 2, 3. We used to do it, and we can call it Q or D. I can call Q, which is my volume domain, and here I just write dz, dy, dx, or basically we write d. The only thing I want, I'm going to write additional work here and just writing this density function, here, and I'm going to be writing like this: rho is a function of x, y, z. So really, bottom line is that when we take the integral, we usually take the integral like x, y, z, dx, dy, dz, or dy, dz, dx, and then we can just write nothing. We just leave it 1 here. Usually we replace this guy by 1. In these kind of problem, if density function is given, you just replace that 1 by density function. Okay. So let's do a problem, simple problem. So we can just take a look into this topic. It's a brief topic, by the way. Suppose that Q is a solid region bounded by x plus 2y plus 3z equals to 6, and the coordinate plane planes and has a density of rho x, y, z equals to x squared yz. find the total mass. Okay, that is write the same expression Q rho and then dV. Now I'm going to substitute the value directly by 3 integral and then density function. My density function is given right here. Where is that? Yeah, right here. So it's going to be x squared y c. Then I'm going to be writing d z dy d z dy and then dx. Okay, I'm going to just set it up. Now it's going to be pretty much integral just like we used to have it. And here I'm going to be writing this equation, the bounded by the region. So maybe it's look like this. The equation of this side is given x plus 2y plus 3z equals to 6. I'm going to take the value of z from here. So z equals to 6 minus x minus 2y divided by 3. And this is a value I'm going to be substituting here. So 0 is z is equal from 0 to z equals to 6 minus x minus 2y divided by 3. Now what I want a value of y. So what I want to do, I'm going to be taking this function again and saying z should be equals to 0 for y. So x plus 2y plus 0 equals to 6 and 2y equals to 6 minus x divided by 2. Then I'm going to take this value and substitute here y equals to 0 and then other side y equals to 6 minus x divided by 2. Third part, I'm going to be taking this and substituting y equals to 0. So this is y equals to 0 to finding the x. So 6 minus x divided by 2. We'll take these guys become 0. So x equals to 6. And I'm going to come here and writing this. X equals to 0 and then x equals to 6. Okay. We're going to solve it just like we solved proper triple integral, and it's going to give you some answer. I'm going to write the answer and you solve yourself and then finding probably something. And the mass is m equals to when you solve this should be equals to 10835. That's a mass. You should be given in kilogram and other units, but I don't know what unit we have in this problem, so we're not going to be assuming anything. Just leave it just a number. That would be our mass. Thank you for watching Knowledge Academy. Please subscribe my channel.